We're now going to turn our attention to a key error handling operator that's defined in Project Reactor's mono class. This operator is called onErrorResume, and it's used to handle errors that occur within a mono chain. The onErrorResume operator can be used to subscribe to a return fallback publisher that will be called when any error occurs. And in this context, an error is typically an exception that's thrown. The parameter that's passed is a function that's used to choose the fallback behavior, depending, of course, on what error or exception happens to be thrown. This returns a mono that falls back on the source if and when an error occurs. The operator will actually swallow the exception so it doesn't propagate further up the call chain or the call stack. And this is both good and bad. The good part about it, of course, is you don't have unhandled exceptions that propagate out of a mono chain. The downside is that it sometimes can be hard to figure out an appropriate value to replace the exception with that's meaningful and still allows something sensible to happen in the program. Let's take a look at an example. We'll take a closer look at this example when we talk about the case study at the end of this lesson. In this example, we're going to have a mono chain that has mono from callable, and it's going to end up essentially dividing by creating a denominator for a big fraction that is 0. So we'll be dividing by 0. We're then going to go ahead and subscribe this to run in the parallel thread pool. And when the divide by 0 occurs, of course, that will throw an arithmetic exception. What we do in this particular case is we interpose an onErrorResume operator, which will have an error handler, which will go ahead and do something sensible. In this particular case, it converts the value that is returned to 0. I'm not entirely sure that's a sensible thing to do, but we'll talk later about ways you can basically use other operators like filters, which are ways of being able to suppress data in order to get rid of zeros and values that are 0. So you'll see how that might be helpful in practice. And of course, if no error occurs, then we'll go ahead and do a multiply of the big fraction constant against the big fraction that we're going to be using from the callable that was divided. If there's no exception occurs, then that'll go and call the map method. But if an exception does occur, then onErrorResume is going to convert it to a 0, which will then do a multiplication by 0. Again, not necessarily the most effective way to handle it, but it demonstrates how we can use onErrorResume to keep the program running without getting an exception to propagate out of the scope. RxJava has an onErrorResume next method in its single class that works essentially the same as onErrorResume does in the mono class. I'm not entirely sure why they have two different names, but that's just the luck of the draw as far as how the designers for RxJava and Project Reactor decided to name these particular methods in their class to handle errors. There's also a method that's part of Java Completable Futures framework that's called exceptionally. And it's very similar to onErrorResume or onErrorResume next in the sense that if an error occurs in a completable future chain, then control will be propagated to that place. And then the appropriate error handling mechanism will be called, which in this case can be used to mask or swallow the exception and return a different value to keep the program running. So this illustrates one way in which you can handle exceptions or errors that arise in a way that helps make the programs more resilient. Remember, that was one of the goals of our reactive programming principles, was to make programs more resilient to partial failures, and methods like onErrorResume for Project Reactor's mono class help to do just that.